Hello class, Dr. Betts here. Today we're going to go over Unit 3, conversion factors and calculations. Let's face it guys, you've got to do conversion factors, you've got to do calculations in chemistry. It's just the nature of the beast. You may as well learn to do it correctly, and you may as well learn to do it the easy way. The easy way is dimensional analysis. Every chemist in the world uses it. You should use it too because it's a powerful technique and, well, quite frankly, you're going to be graded on it. So let's learn how to do it correctly. In Unit 3, we're going to learn about converting distances, converting temperatures, converting masses, and converting volumes. Let's talk about dimensional analysis. In every dimensional analysis question, in every conversion question, for the most part, there are exceptions, you're going to read the question carefully and you're going to get what's called the given unit. So for example, if a question says, a child weighs 8 kilograms. Well, the given unit is kilograms, and the given value is 8 kilograms. Given unit, kilograms, given value or given number is 8. How many pounds is this child? Well, okay, now the needed unit is pounds. We started in kilograms, we want to get to pounds. So given, kilograms, needed, pounds. And in dimensional analysis, the given unit is always what starts the question. The given unit always starts the question. The given unit is repeated down here. Always, always, always. This unit is written here. The needed unit is written in the end after the equal sign and in the numerator. It's written in both locations. Why do we do that? Because we want the given units to cancel and we want the needed units to stay behind. That's what we're trying to get to. Okay? The given units cancel, the needed units stay behind. Let's see an example. The width of a building is 125 feet. How many meters is this? 1 meter equals 3.28 feet. All right, so in this question, the given unit is feet. So I wrote given unit equals feet. How many meters is this? The needed unit is meters. We want to go from feet to meters. So again, given unit is written here and repeated here, always. The needed unit is here and then printed here, always. The given unit will cancel, leaving us in the needed unit. So here's the setup. The given unit, feet, is written here. The given unit, feet, is written in the denominator. The needed unit, which is meters, is written in the numerator and repeated after the equal sign. That's the proper dimensional analysis setup for converting feet to meters. Now, let's put some numbers in. Given unit, feet, came with the given value, 125. So that number is written there. We have a equality over here. 1 meter equals 3.28 feet. So 1 meter, sorry, the colors are backwards, is 1 meter, 3.28 feet, 3.28 feet. Notice the 3.28 feet went together. 3.28 remained with the feet the entire time in the equality and the conversion factor. The 1 meter stayed the entire time in the equality and in the conversion factor. Those don't change. Okay, grab out your handy dandy calculator. You simply type in to your calculator 125 feet, or just 125, obviously your calculator probably doesn't use units. 3.28 divided by 3.28 equals 38.1 meters. Okay? Now the feet cancel, the meters don't. That's dimensional analysis in a nutshell. Now we're going to do part 3. Now part 1, we're going to do something kind of interesting. We're going to experiment with the equality for centimeters to inches. It's known or accepted that 1 inch is 2.54 centimeters. That's written in books. You can look that up online. We're going to experiment with that using our own ruler. We're going to measure the length of something in our home, maybe your calculator, or your cell phone, something small, and we're going to determine its length in inches and in centimeters. And we're going to compare them, and we're going to see how close we can get to the accepted value of 1 inch equals 2.54 centimeters. Now, I want to warn you right now, don't use my numbers. The numbers I'm using here are mine. Don't you use them. Use your own numbers. I'm going to show you the process to do it, how you would do it yourself, but don't use these numbers. Okay? All right. So we have an inch ruler here, or an English ruler. And notice there's a bunch of tick marks between, say, 2 and 3. So it's between 2 and 3. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wow, there are 16 lines between 2 and 3. Unlike in metric, say between 7 and 8, there's only 10 lines between these two, right? That's because metric is measuring in the tenths. 7.1, 7.2, 7.3 centimeters is on that ruler. The English rulers are not measuring in tenths. They're actually measuring in sixteenths. That's because there's 16 little divisions between 2 and 3. So English is written or measured 2 1/4, 2 1/8, 2 1/32, 2 7/16. It's written like that. It's written by a fraction. Don't ask me why. It's a holdover from a long time ago, I'm sure, and we're still dealing with it. It's not a problem. It's not a problem. I'll show you how to do it. It's very simple. Here's 3, and here's 4, and here's our line. Well, our line is obviously greater than 3, but less than 4. So write down 3. It's 3 something. Now, it's not just 3, because 3 is right here, right? If it were 3, the line would be much shorter. So it's not 3. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. It appears to be close to 9. It's a little bit less than 9, but let's just take 9. So this is 3 and 9 over 16 inches. 3 and 9 over 16. Now, we're going to want to convert that to decimals to use our calculator. So let's do that right now. Take 9, divide it by 16. And it gives you a decimal. So it's 3.5625 inches. Okay? Now let's go down to our centimeter ruler. Centimeter ruler says this line is 9.10 centimeters. Let me make that a little bit larger. There we go. Okay, so now this line, it's the same line. It's the same line. I measured it with the metric ruler, the English ruler, and the metric ruler. So I can say with all confidence that 9.10 centimeters equals 3.5625 inches. I can say that with all confidence. But I don't want to know how many centimeters are in 3.526 inches. I want to know how many centimeters are in 1 inch. So all you have to do is divide both sides by 3.5675. That will cancel to give you the number 1. 3, but you do to one side of an equal sign, you must do to both sides, right? Don't forget your math. 3.5675. So now I'm going to take 9.10, divide it by 3.5675 equals 2.55 centimeters equals 1 inch. Not bad. Not bad at all. The accepted value is 2.54, and we calculated 2.55. Not bad. Not bad. Maybe we could do it again, do it a few more times, and maybe get a little closer, but that's not bad. And that's how you do part 1. That's how you do part 1. Make sure you don't use my numbers. In part 2 of today's experiment, we'll be working with temperatures. We'll be converting Fahrenheit to Celsius, Celsius to Fahrenheit, and Celsius to Kelvin. Temperature conversion is all formula-based. We don't really use dimensional analysis for it because it's easier just to apply a formula. Now, the formulas will be given to you on the exam, so you don't have to worry about memorizing them. You just have to know how to apply them. In today's example, I'm going to be just doing Fahrenheit to Celsius, Celsius to Kelvin conversions, but in the data sheet and on an exam, you may be required to convert Celsius to Fahrenheit. So be prepared for that. It's not a big deal. So let's read this question carefully, this little example. The temperature on the far side of the moon is negative 387 degrees Fahrenheit. What is the temperature in Celsius and in Kelvin? Well, here are our three formulas right here. We know Fahrenheit, we don't know Celsius, and we don't know Kelvin. Okay, well, it's very simple. You take this number and you plug it into that and do the calculation. Very, very simple. So equals negative 387 minus 32, close parentheses, open parentheses, divide everybody by 1.8. Grab out your handy dandy calculator. Negative 387 minus 32, divide everybody by 1.8. You get negative 232 degrees Celsius. That's it. That's the temperature in Celsius. So very close to absolute zero. Let's see how close it is. Kelvin. Now just plug in the Celsius temperature right in here. Negative 232 plus 273.15 equals 40 Kelvin. So very cold on the far side of the moon. Okay? And that's how you convert with temperatures. It's very simple. It's formula-based. I'll give you the formulas on the exam. You don't have to memorize them. Just know how to apply them. In part 3 of today's experiment, we'll be converting masses. Now, converting masses is exactly the same as converting distances or converting volumes or whatever. You just use dimensional analysis. As long as you know the equality between the two units you're trying to convert from, you're golden. It's very simple. All right, let's read this question together. What is the mass in kilograms of a 193-pound patient? All right, 193-pound patient. Well, that's the given unit, right? Pounds. Given unit is pounds. The given value is 193. So here, I wrote down the given unit and value, 193 pounds. I want to get to kilograms. How do I know that? What is the mass in kilograms? So that's what I don't know. So I put a couple question marks here. Kilograms. The needed value is question mark right now. We don't know what the needed value is. We have to calculate it. Again, just like always, given value, given unit is here. Given unit is here. Needed unit is on top. Needed unit is over here. Very simple. 193 is the given value. Plug that in down here. Now, this is where students often make mistakes, so let's be careful here. 2.20 pounds. 2.20 pounds. Remember, in the equality, this value and its unit are always together. This value and the unit are always together. 1 kilogram, 1 kilogram. So now, you bust out your handy dandy calculator. 193 divided by 2.20 equals 87.7 kilograms. It should look very similar to the dimensional analysis example we did earlier, in that we took a distance and converted it. We had feet, I believe, and went to meters, however it worked. And that's how you do it. That's dimensional analysis. See how powerful it is, how it can just lead you to the right answer? It's a very powerful. In part 4 of today's experiment, we'll be converting volumes. Again, it's the same idea as converting distances, as converting masses. Now we're just doing it in volume. Very, very simple. How many liters are in 15.3 gallons of milk? Again, read the question carefully. Pull out the given value and the given unit and the needed unit. All right. How many liters? Okay, so the liters are the needed unit. We don't know what the liters are. We have to figure that out. Are in 15.3 gallons of milk. So gallons is the given value and unit. 15.3 is the needed, the given value. Gallons is the given unit. Again, just like always, given unit is here, given unit is here, just like always. Needed unit is here, needed unit is here, no problem. Given value goes with the given unit down here, 15.3, 15.3. Now we have to work on the conversion factor. Again, you have to be careful with the conversion factor. You're given the equality right here. You have to be careful to translate it to a conversion factor correctly. 1 gallon, 1 gallon. 3.59 liters, 3.59 liters. You just write it there. And then now you just take 15.3, multiply by 3.79, and you should get 50.8 liters. I'm going to grab my calculator and do it for us real quick. Make sure. 15.3 multiplied by 3.79 equals. I rounded up to 58.0 liters. And that's how you convert. That's, again, it's dimensional analysis. I'm hoping that you're seeing, aside from temperature, all of these questions are essentially the same. You're using dimensional analysis to solve the problem. And with that, I want to wish you all good luck and good chemistry. We'll see you soon.